Hello, everyone, and welcome to FinOps and AWS Cloud Optimizations. And hopefully, I'm going to help you save some money on your cloud. So let's get into it. So first, let's start talking about FinOps and maybe the four steps that's relevant to implementing FinOps at your company. The first one would be tagging everything, tagging every resource you have in the cloud. And this should be done by multiple dimensions, everything that's relevant to your company. Can be dividing it by teams or by features or different products, whatever works for you. What you really want to make sure is that you automate tagging, and you need to automate it by two ways. First, when creating, and then adding also a layer of validation. So, for example, for automating, here is an example of a Terraform module that we developed in Sygnia to enable every developer to attach it very easily to the resources that he's creating to make sure he's getting the right tagging with the right formatting without even thinking about it. The second thing is validation. So we use AWS config to define a set of rules to detect if resources are created in the cloud without proper tagging. For example, in this case, we have a network interface that's missing some tags. After we tagged everything, the next thing is getting visibility into your cloud bill. And what you want to do is really use either the native AWS Explorer or any kind of system that allows you to have cloud bill exploration and visualize your data according to different metrics. So it can be per tenant or customer, per service, per team, whatever you think is the right analysis for your company. After you have visibility into your build, the next thing would be to track it. So getting Slack integration and reports, sending it to your mail every week or every month, and tracking for substantial changes in your build. And the last part is, of course, getting the insights and doing the real work. So you want to identify the top spend factors where you can get the most price reduction, understanding the true cost, and I'll deep dive into that term in a second, but basically understand what really is costing you the most money, and deep dive into the specific services and make the changes either in your architecture, configuration, or your code. The first thing you want to do is define a goal. Where do you want to get to? It can be maybe a number like a monthly bill or a yearly bill, a percentage of saving, or how much you want a single tenant to cost you. The next thing would be to define constraints. What can and can't be done? Can you hit your SLA somehow? Can you make maybe application changes that will help you make price reduction? And really understand the rules of the game you're playing here. And lastly, you want to have one business unit cost, which is a normalized unit. For example, how much does one customer cost me? And that helps because if, for example, your number of customers gets twice as large, which is a good thing, you can understand why your bill got twice as large and not be afraid of it. Now, it's important to really understand thoroughly your cloud, in this case, AWS. But unfortunately, knowing AWS very good does not help all the time, as you can see here. So the first thing, and probably this would appear in the top of your bill, is EC2. The first thing to get right is instance types and utilizations. Making sure you choose the right instance types to your application and making sure that they are utilizing the money correctly. What we like to do is actually define Datadog alerts to understand if we have servers that are underutilized. Another thing is Graviton 2 or even Graviton 3 right now, which is a whole revolution on its own. Basically, it's ARM-based processors provided by AWS, which provide cheaper cost with faster processing. And this can be actually used in RDS and Elasticache, for example, without even changing anything in your app, because it's running EC2 behind the scenes for you without compiling anything and so on. So you can go to your configuration, change to a Graviton 2 processor, and save money right away. The next thing is developer environments, where you can use T3 instances or spot instances, or have a shutdown policy. So, for example, shutting it down on nights, on weekends, or time that you're not using it to get very big price reductions. Another thing is GP3 is making sure you're using the latest generation disks from AWS, which are actually 20% cheaper than the previous one, GP2. And this can also be achieved with one click in your AWS without any changes on your code. And really what you want to do is actually stay up to date with AWS news, because these contain on a weekly basis a lot of changes from AWS that can help you save money. And here are some examples from the last couple of years. So really new instances every few months that can, in these examples, up to 30% price reduction. So read the blog, it's really good. Next is networking. And when we talked about the true cost of things, is when you have a server, the true cost of the server is not only the running time of the server, it's also the storage, and it's also the networking, which will probably appear very at the very top of your bill. You want to be careful from outbound communication, and you want to be careful from cross-region, cross-availability zone communication, because these cost a lot in AWS. And what you can do is use VPC endpoints or private link to avoid going out to the internet just to reach another VPC or just to reach AWS. A nice example from Sygnia is where we have a very large Elasticsearch clusters, and in Elasticsearch, nodes communicate to each other to sync the data. We added 2 lines, and this is a true screenshot from a PR we did, which adds compression to the communication between the nodes and compresses them. And we actually saw a very big price reduction, about 50% price reduction for networking for Elasticsearch. So this was a really nice win for us. Next is S3. Again, one of the most popular services of AWS. And the price differences from S3 comparing to GP3 SSD disks is huge. And SSD also allows you, S3 also allows you to move data into lower tiers if you're not using the data so often. And you can see in the following chart what's the price in AWS for storing 10 terabytes of storage. So you can see it's a huge difference from $800 a month until basically 90 cents per terabyte per month that you can achieve in the lowest tier in S3. So this is a very nice price reduction if your application needs fits these changes. Another one is SQS. SQS is the queue service in AWS. And this is an example where you really have to have a good pricing understanding of how it works, because SQS works in billable units in 64K. So even if you send one batch of 256K, you're actually paying for 4 units. So you can do some really smart batching and making sure you're hitting those 64K units nicely, which is what we did. But also we wanted to lower our transfer costs, which were very, very big. So one thing we did is actually added compression. So we tracked the sizes of the messages that we're sending to SQS and added compression and got a very big price reduction, because we were sending JSON objects into SQS, which are very compressible. So we got maybe almost an 80% price reduction just on networking costs in SQS itself. Another peculiar example is availability zone endpoints. So our application is running on 3 endpoints, and we assumed that every application running on a specific endpoint would communicate with the endpoint designated to the specific availability zone. However, we saw very big cross-AZ charges in our bill. When we looked into the server, we saw that every server is actually communicating with 3 IPs, each for every availability zone. And that was very weird for us. So the real reality looks like this. Every server is contacting through all of them, and the red lines are actually communication that you're paying a lot of money for. What we do is we actually, first of all, we contacted AWS and informed them about this. But second, we actually developed code in our application that understands in which availability zone does it run, and then chooses the specific availability zone interface to communicate to. And this was a very nice price reduction. And basically, right when it hit production, it was a very big success. AWS also informed us that they're making a change and actually reduced it for every client. So we had to revert our code, but it was a win anyway, and got a very nice price reduction. Lastly, Kubernetes. Can't talk about price reduction without mentioning Kubernetes. So first of all, Kubernetes can help you just on its own without any fancy features, just because you're sharing infrastructure and running everything on a better utilization servers. Um, it can also help you avoid over provisioning or handling peaks with horizontal pod autoscaling. Specifically, we use Keda, which is an open source alternative to the default autoscaler. One thing, there's a lot of nice things about Kera, but one specific thing is that it can scale down to zero, meaning that if you don't have traffic for a specific service, you can actually have no instances running, which is another great price reduction. Vertical pod autoscaling and right sizing is something that is very, very hard to get right. But there are some tools around to help you achieve that. And you can also combine it with horizontal pod autoscaling, which is called multi-dimensional pod autoscaling, but that is still a beta in Kubernetes. Another thing is pod instances. So in Sygnia, we transformed all of our Kubernetes cluster to run on spot instances, which required our application to be stateless and resilient for changes, but got us up to 80 or 90% discount for the servers in some cases, which is very, very nice. So in summary, really want to start by defining your goals, understanding what are the constraints, what you can and can't do, and what's your business unit. What are you really measuring? Next, you want to tag everything automatically and get visibility into your billing data and track it across time. Then understand the top spend factors and drill down into those specific cloud provider services to understand what changes you want to do. And prioritize your actionable insights and make the actual changes either in your infra, your configuration, or your code. I hope this session helped you understand a little bit about how to save money in your cloud. And if you have any questions, feel free to reach me on Twitter or at my email. Hope you have a great rest of your conference. Bye-bye.